We're going to start our discussion of chemical bonding with a little bit of a review from Chapter 1 on the difference between mixtures and compounds. So let's take a look at mixtures first. So remember that mixtures are basically just multiple substances combined in the same container. Or we could describe it as just multiple substances mixed together. So remember, we talked about the examples of wet sand or tea with sugar. So both of those are just kind of multiple components all mixed together, but there are still distinctly different substances in all of those components. Like here you can see the H2O molecules with these molecules that I think are supposed to represent sugar. And then here we have our H2O molecules, and we have various sand particles down there. So different substances just all mixed together. That's different from a compound because the compound is multiple atoms bound together to form one single substance. So multiple atoms are bound together forming one substance. So as you can see, if we look very closely at these molecules, we have our red oxygen molecules, oxygen atoms. And those are bound to 2 hydrogens each. So each one of these is a molecule of H2O. And that is an example of a compound. And in particular, this compound uses covalent bonding, and this is what we're about to start talking about. First, we're going to talk about ionic bonds, though. So there are 2 types of bonds. We mentioned covalent bonding a second ago. The other type is ionic bonding, so we're going to compare and contrast these 2 types of bonds. So ionic bonds are usually formed between an interaction of a metal and a nonmetal. And there are some exceptions to this, but we're not going to focus on those right now. So right now I want you to focus on ionic bonding being between metals and nonmetals. And how do these actually interact? Well, the metal loses an electron to form a cation. So the metals lose an electron, and they form a cation. And the nonmetal is going to gain that electron. So I like to use the this E- sign as an abbreviation for electron. So what are cations? What are anions? So the cation is going to be a positively charged particle. The anion is going to be a negatively charged particle. So what does that look like? So I'm going to attempt to draw a picture here of an ionic bond. So imagine that we have this ionic compound, lithium fluoride. So lithium here is our metal, fluorine is our nonmetal. So take a look at the periodic table. You can see that lithium, in its neutral state, has a total of 3 electrons. So I'm going to just draw 3 electrons around it. So that's going to be lithium with its 3 electrons. Fluorine, on the other hand, is our nonmetal. And if we look at the periodic table, it has 9 electrons in its neutral form. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I didn't draw those in any particular place or in any particular order. We'll get to the ordering of electrons later on this semester, but for now, fluorine in its neutral form has 9 electrons. So what happens in an ionic bond is that the metal is going to lose one of these electrons, and then the nonmetal is going to gain it. And that's going to leave us with lithium having lost one of its electrons, so it still has these two, but it's missing the one that moved to fluorine. So that is going to give lithium a positive charge, which turns it into a cation. And then our fluorine has gained an extra electron. So I'm going to draw the 9 that were already there. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then remember that fluorine just gained this electron that it stole from the lithium. So now that it has an extra electron, that fluorine has a negative charge. And those positive and negatively charged particles are what we call ions. So remember, ions are positively and negatively charged particles, and they are positively or negatively charged because they have a different number of electrons than they would in their neutral form. So how does that differ from covalent bonding? So remember, covalent bonding is the type of bonding that shows up in things like water, like H2O molecules. So the difference is that covalent bonds, the first thing I want you to look at is what type of atoms are interacting. So here, these are usually going to be nonmetal and nonmetal interactions. So for ionic, if it's an ionic, it's going to usually be a metal and a nonmetal. For covalent, I want you to think nonmetal plus nonmetal. So you have to look at the type of atoms that are interacting. And covalent bonds are going to be more of a sharing of electrons. Rather than transferring from one atom to another, covalent bonding is going to be an example of sharing electrons. And compounds that contain covalent bonds, we have a special name for them. This is a name that you have heard multiple times before, but those are called molecules or molecular compounds. So getting into the definitions of what these actually are. So molecules or molecular compounds these are compounds that contain covalent bonds. Okay, so what do these covalent bonds look like compared to the ionic bonds we looked at before? So this time, instead of LiF, because that would be a metal and a nonmetal, we're going to look at F2. So a molecule of pure fluorine. Fluorine is diatomic, so two of these fluorine atoms combine together to form a molecule in its most stable form. So the way that works is we have our two fluorines, And each one in its neutral form has a total of 9 electrons. 7 of them are what we call valence electrons, and again, we are going to talk about that later on this semester, but for now, we just look at the periodic table and we can tell that it has total 9 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This one also has 9. 4, 5, 6, 7, 8, 9. So in order to be really stable, these atoms want to have the same, what we call electron configuration as a noble gas. So take a look at your periodic table, and you can see that the noble gases have one more electron than fluorine does, which means that in order to be stable, each of these fluorines is going to want one more electron. But that's kind of confusing. How do we do that? If we take one electron away from one, then it's going to need 2 more electrons. So what they do is they form a covalent bond and share 2 electrons. So now this electron is going to be part of both atoms, and this electron is going to be part of both atoms, so it creates a bond. They are sharing those electrons, and that interaction of the 2 electrons is our covalent bond. And that forms this bond between these 2 fluorines and creates our F2.